For generations, humanity has wondered, are we alone in the universe? Our search for life has taken us from the rocky planets to the far reaches of our solar system. Now we turn our gaze to the icy moons orbiting the gas giants, places where life might exist in the most unexpected conditions. Among these, one world stands out, a frozen moon of Jupiter, shrouded in mystery and scientific promise. NASA is preparing to send a robotic explorer to this distant world, hoping to answer one of our oldest questions. This mission is more than science. It's a leap into the unknown, driven by curiosity and hope. We are about to embark on a journey that could redefine our understanding of life in the cosmos. The next great step in our search for life begins now. Meet the Europa Clipper, NASA's most advanced spacecraft yet. Its mission to investigate Jupiter's moon Europa, a world with a hidden ocean beneath its icy shell. Europa's surface is a frozen expanse, but evidence suggests a vast ocean lies below, possibly twice the water of all Earth's oceans. The Clipper won't land, but will perform dozens of close flybys, gathering data while dodging Jupiter's intense radiation. Its instruments will search for signs of water, essential chemicals, and energy sources, key ingredients for life. By studying Europa's surface and subsurface, the Clipper could reveal if this moon is habitable. The mission is a bold step, laying the groundwork for future exploration. The data it returns could transform our view of life's possibilities. Europa Clipper carries our hopes to a distant ocean world. Europa is more than a frozen moon. It's a world of hidden depths. Its cracked, icy surface conceals a global ocean, possibly 100 kilometers deep. This ocean may hold more water than all of Earth's combined. Evidence comes from spacecraft data, a young active surface, magnetic readings, and even hints of water plumes erupting into space. Unlike Mars, whose water is mostly gone, Europa's ocean exists today. Water is essential for life, making Europa a prime target in our search. NASA's Europa Clipper will investigate this living, dynamic environment. We're not just chasing ancient habitability, we're searching for life in the present. Europa could be home to a thriving ecosystem, isolated from sunlight. The secrets of this ocean world may soon be within our reach. How can Europa's ocean stay liquid in such a cold place? The answer? Jupiter's immense gravity. As Europa orbits, Jupiter's pull flexes the moon, generating heat through tidal forces. This tidal heating keeps the ocean from freezing, powering possible hydrothermal vents on the seafloor. On Earth, similar vents support life in total darkness, fueled by chemical energy. Europa shows that habitable worlds can exist far from a star's warmth. Gravity, not sunlight, could power life in these hidden oceans. This expands our idea of where life might exist, across the galaxy, not just near stars. The Europa Clipper will study this gravitational dance, searching for signs of a living world. Jupiter's embrace may be the key to life beneath the ice. Life needs three things: liquid water, energy, and the right chemicals. Europa's ocean has water and energy from tidal heating. But what about chemistry? Scientists believe Europa's rocky seafloor could supply essential elements like carbon, nitrogen, and sulfur. Hydrothermal vents may infuse the ocean with nutrients, just as they do on Earth. Meanwhile, radiation from Jupiter creates reactive chemicals on the surface. If these chemicals mix into the ocean, they could fuel life. Europa's ocean may be a rich chemical soup, a potential cradle for biology. The Europa Clipper will search for these ingredients, testing if this distant moon is truly habitable. If all three are present, Europa could be one of the best places to find life beyond Earth. Our search for life's recipe is about to reach a new frontier. The Europa Clipper's voyage began on October 14, 2024, from Kennedy Space Center in Florida. Carried by a SpaceX Falcon Heavy, its roar echoed across the coast. This launch, the culmination of a decade of work, propels the mission towards the outer solar system. Dedicated to unlocking Europa's secrets, the Clipper began its solitary cruise. Its massive solar arrays capture faint sunlight at Jupiter's orbit. These power the instruments for the mission's core investigations. Humanity's robotic emissary is now on its way, a quest that could reveal if we are alone. It carries our dreams to a distant, icy moon. The journey to Jupiter is a long and winding path. The Europa Clipper's voyage will span nearly 6 years. This is necessary due to the immense distance. It will execute a gravity assist, using the gravitational pull of other planets to slingshot itself deeper into space. In February 2025, The Europa Clipper will perform a gravity assist flyby of Mars. Then, in December of 2026, it will swing by Earth for a final gravity assist. This will set it on its final course toward Jupiter. The mission team will be monitoring the Clipper's health and performance. For 6 years, its primary goal is to survive the harsh environment of deep space. Finally, in April of 2030, the Europa Clipper will arrive at its destination, officially entering orbit around the planet. This will mark the beginning of its primary science mission and start unveiling the secrets of the mysterious moon. Once in the Jovian system, the Europa Clipper won't orbit Europa itself. This is a deliberate part of the mission's design. The region around Jupiter is hazardous, thanks to its powerful magnetic field and intense radiation. This radiation would quickly fry a spacecraft's electronics. To protect the Clipper, mission planners devised high-speed flybys. The Europa Clipper will be placed in a long, looping orbit around Jupiter, intersecting with Europa's path. The spacecraft will perform approximately 50 close encounters over 4 years. During each flyby, the Clipper will fly as close as 25 kilometers above Europa's surface. Its instruments will gather high-resolution data. This flyby strategy allows the spacecraft to collect detailed information about Europa while minimizing its radiation exposure. This extends the life of its instruments. Each flyby will target a different region, building a comprehensive global map. This approach also makes the mission more adaptable. This flexibility is key to a mission of discovery. The flyby strategy is a clever solution. To unravel the mysteries of Europa, the Clipper spacecraft is equipped with 9 scientific instruments, a comprehensive toolkit designed to investigate a specific piece of the puzzle and paint the most detailed picture of Europa we've ever seen. Is there an ocean? What is the ice shell like? Does Europa have the ingredients for life? These instruments are the heart and soul of the Europa Clipper mission. To protect them from Jupiter's intense radiation, the most sensitive electronics are housed within a heavily shielded vault. Ultimately, the Europa Clipper is a robotic proxy for human curiosity. Its toolkit is our toolkit, allowing scientists back on Earth to explore Europa in unprecedented detail. Ready to transform our understanding of Europa into a complex and dynamic world with the potential for life. The Europa Clipper's ice-penetrating radar Reason will be our first direct look at Europa's frozen shell. It transmits radio waves into the ice, listening for echoes that bounce back, especially from the ocean below. This will measure the ice shell's thickness, fundamental to assessing Europa's habitability. Reason will map the icy landscape in 3 dimensions, revealing its layers and search for subsurface lakes like those in Antarctica, potentially habitable environments. The echoes will reveal the shell's internal structure, showing how Jupiter's tidal forces have deformed it. This ability to peer beneath the ice is a game-changer, giving us a direct measurement of the world below and confirming the ocean's existence. Reason is our deep-seeing eye, poised to reveal Europa's hidden architecture. While the radar looks down, another set of powerful instruments will be focused on Europa's surface, meticulously scanning its composition for clues about the ocean below. The surface of Europa is a vast frozen canvas that records the moon's history and its interaction with the ocean. Chemicals from the ocean that find their way to the surface, perhaps through cracks or plumes, would leave behind a telltale residue. The Europa Clipper is equipped with a suite of cameras and spectrometers designed to find and identify these chemical fingerprints, especially those related to life. These instruments will analyze the light reflected from the surface to determine precisely what materials are present. The mission's main camera system, known as Europa UVS and EIS, will not only capture breathtaking, high-resolution images but will also operate across a wide range of wavelengths, from visible light to the ultraviolet spectrum. This allows scientists to identify different types of ices and salts. For instance, the presence of certain salts like magnesium sulfate or sodium chloride, yeah, that's common table salt, would tell us a great deal about the chemistry of the ocean and how it interacts with the rocky seafloor. More excitingly, these instruments will be on the hunt for organic compounds, the carbon-based molecules that are the building blocks of life as we know it. Finding complex organics on the surface would be a monumental discovery. These surface scans will be targeted at Europa's most interesting geological features. The mission will focus on the strange, chaotic terrains where the ice appears to have been broken up and refrozen, and along the dark, reddish-brown cracks that crisscross the globe. These lineae are thought to be areas where ocean water has welled up from below, bringing dissolved minerals with it. The reddish color could be caused by salts that have been blasted by Jupiter's radiation. By analyzing the precise composition of these materials, the Europa Clipper can effectively taste the ocean from dozens of kilometers away, providing our first direct chemical analysis of this alien sea and assessing its potential to support life. Another key instrument, the thermal imager, e-Themis, will create a heat map of the surface. It will search for hotspots, areas that are slightly warmer than their frigid surroundings. Such a thermal anomaly could indicate recent geological activity, such as a spot where the ice shell is thinner or where warm ocean water is close to the surface. It could even be the smoking gun that points to an active plume erupting water into space. By combining these surface composition maps with thermal data and high-resolution imagery, scientists can build a complete picture of Europa's geology and chemistry, identifying the most dynamic regions and the best places to look for signs of habitability. Perhaps the most thrilling possibility for the Europa Clipper mission is the chance to directly sample the ocean without ever touching it. Observations from the Hubble Space Telescope have suggested that Europa, much like Saturn's moon Enceladus, may be venting massive plumes of water vapor into space. These geysers are thought to erupt from cracks in the ice shell, blasting material from the subsurface ocean high above the moon's surface. If these plumes are real and are active when the Clipper flies by, the spacecraft could fly directly through one. This would be an unprecedented opportunity to analyze the ocean's contents up close, providing the closest we have ever come to sampling an extraterrestrial ocean. To seize this potential opportunity, the Europa Clipper is outfitted with instruments that can sniff the particles and gases in the space around Europa. A mass spectrometer called MassSpecs and a dust analyzer, SUDA, are specifically designed for this task. As the spacecraft passes through a plume, these instruments would scoop up tiny ice grains and gas molecules and analyze their composition on the spot. They can measure the exact makeup of the plume material, identifying the types of salts and minerals, and most importantly, any organic molecules that might be suspended within the water. This would be a direct line of evidence, telling us what is in the ocean right now. Flying through a plume would be a mission-defining event. It bypasses the immense challenge of having to drill through miles of ice. Instead, Europa would be obligingly serving up a sample of its ocean for us to analyze. Discovering complex organic molecules, such as amino acids or lipids, within these plumes would be a watershed moment in the search for life. While not proof of life itself, it would confirm that Europa's ocean contains the necessary building blocks and would elevate the moon to the very top of the list of places to send a future life detection mission. It would be a tantalizing hint that the dark, hidden ocean below is a chemically rich and dynamic environment. Even if no active plumes are found, these sensitive instruments will still play a vital role. They will analyze the extremely thin atmosphere or exosphere that surrounds Europa, which is created by charged particles sputtering molecules from the surface ice. By studying the composition of this tenuous gas cloud, scientists can still learn a great deal about the surface ice and, by extension, the ocean beneath. Whether it samples a plume directly or analyzes the faint whisper of gas around the moon, the Europa Clipper is poised to give us our first taste of an alien ocean, sniffing the breath of this distant world for any hint of habitability. The Europa Clipper mission is a quest for one of the most profound discoveries in human history, the hunt for life. It seeks a second independent tree of life, a second Genesis. Finding even basic microbial life in Europa's ocean would revolutionize biology and reshape our understanding of the universe. It would suggest life is common where liquid water, energy, and chemistry converge, making the universe seem much more alive. This would challenge our place in the cosmos and force us to reconsider what it means to be a living being. Even without finding life, characterizing Europa's ocean will provide a roadmap for understanding potentially life-bearing worlds. The Europa Clipper mission will mark a pivotal moment in understanding our place in the universe. The Europa Clipper mission may dramatically expand our definition of where life can exist. For much of modern history, our search for habitable worlds has been guided by the Goldilocks principle. But Europa challenges this paradigm entirely. Yet it may be one of the most promising abodes for life in our solar system. If gravitational flexing from Jupiter truly provides enough energy to sustain a liquid ocean, it means that habitable zones are not just defined by proximity to a star. This would open up the possibility that countless icy moons orbiting giant planets could be habitable. This redefinition of habitability has profound implications. It suggests that life may not need sunlight to thrive. Discovering such an ecosystem would prove that life can be incredibly adaptable. We are testing a fundamental concept that could reshape the entire field of astrobiology. Europa may be the proof of concept that life can find a way in the most unexpected of places. The Europa Clipper is the critical opening act in our exploration of this ocean world. It lays the groundwork for a future mission that will one day land on the surface. Every piece of data the Clipper collects is vital for planning such a daring follow-up mission. The Clipper maps the terrain and identifies the most promising targets for future exploration. The radar data will reveal where the ice shell is thinnest and most accessible for a future drill. The ultimate dream is a future mission that could deploy a submersible to swim freely in the alien ocean below. The Europa Clipper is the necessary first step to make it a reality, giving engineers the parameters they need to design the next generation of robotic explorers. The Europa Clipper mission is an investment in the future of space exploration. It will inspire and inform a new generation of scientists and engineers. The Clipper is our first dedicated step, paving the way for the day when humanity finally dips its toes into an extraterrestrial sea. The Europa Clipper's grand odyssey is underway, unfolding over the next decade. Having launched in October 2024, the spacecraft is on its interplanetary cruise, using gravity assists from Mars and Earth. In April 2030, it will arrive at Jupiter, beginning its scientific mission. For 4 years, the Clipper will perform about 50 close flybys of Europa, gathering data. We can expect a cascade of discoveries, new images, radar soundings, and chemical analyses. This will reveal the secrets of Europa's icy shell and ocean. The data will be analyzed by teams worldwide, piecing together the puzzle of this moon. The mission's data will shape planetary science for decades, guiding future missions in our search for life beyond Earth. As the Europa Clipper sails toward Jupiter, it carries human curiosity and our desire to venture into the unknown. This mission declares that we are determined to see what lies beyond. The Europa Clipper represents a promise to future generations that we will continue to explore. What secrets are locked beneath Europa's ice? Soon, we may have the first clues to these questions. The potential discoveries of this mission have the power to unite us. Even if no life is found, the exploration itself is a victory that inspires a new generation. The Europa Clipper is a magnificent step along that endless path. It is a symbol of our hope, ambition, and relentless spirit of exploration. Thanks to this incredible mission, we are closer than ever to finding out what lies beneath. The journey continues and our future among the stars awaits.